be that there's a stage where it goes 1, 2, 3, 4, many, before you get to going 1, 2, 3, 4, 5, 6, 7, 8, and so on? Well, because when you're learning number words, what you're doing is you're learning to count your visual tags. That's phase 1 of learning number words, where you go 1, 2, 3, 4. And then it's a separate phase in learning the number words to get beyond that, to crack what's happening after that. Or another way, which is a fertile idea, is children are popularly supposed to go through phases in learning about physical objects. So if you take an object, here I have a simple object, and you hide it, children are said to have a lot of trouble with the idea that it's the same object when it's recovered after having been hidden, right? So they're thought to have this problem with their parents in particular, right? That's a real challenge, right? I mean, if it's not, how can it be the same object if it disappeared, right? Well, you can think of phases in learning the object concept, learning that concept of an object that sticks around, can disappear from you, and then come back, as training your use of visual indexes, training in the visual system, so that a fancier version of this test would involve the objects going behind occluders, right? So you might have barriers here that the targets you're trying to keep track of disappear behind, and then the question would be, are you managing to keep track of them? People do manage to keep track of, I should have put one of these up actually, but people do manage to keep track, do the task pretty well, even when the objects are going behind occluders. So that idea of it being the same object, even though it's disappeared for a while, is built into your use of those tags. It can be trained into your use of those tags. So this is a very fertile idea, this idea of tags in the visual system, in a lot of different ways. Yep. Yeah. At a glance you can see the roll single. Yeah, very good, yeah.
But then it seems like the object outstrips the tags.
The object outstrips the tags. Very good, yeah.
So we can apply properties on it.
That's right. You can apply properly without applying this. What you're doing, yeah, I strongly agree. I wish you can see that every word there is black, for example, yeah, without having to count them all or tag them all, yeah. And that is a good point. So one way of thinking of what you're doing when you say they're all black there is, well, you're saying this one's black and this one's black and this one's black, and some big conjunction, right? But and then that really would be mysterious in this account, because how come you've got 50 tags there, yeah, or however many words there, letters there are there. But I think that's not quite the right way to think of it. What you've got is all these shapes, right? And what you've done is you've lifted out all these shapes simultaneously and said that whole area is black, right? So there's just one large discontinuous area here, yeah, and you said the whole thing's black. You see what I mean? You haven't really noted each object and taken them all one by one. You've lifted out all that region simultaneously of all the letters and said that whole region is black. Yeah. Anyway, that's an analysis to explain what's going on here. Yeah. Yep.
Can I ask what you're saying?
Yeah.
What about Mr. Schroeder? Like savants and sort of can glance at 50 objects, 50 some objects.
Isn't that interesting? Yeah. And say that's 50. Yeah.
I mean, I'm trying to think of ways that maybe that there's rapidly
Yeah.
grouping them.
You're way ahead of me. Everything you said there was I was just a few hundred milliseconds behind. Okay. Yeah, I don't know of any cases. Do you guys know? I haven't come across any cases like that. I don't see why there shouldn't be. I mean, usually if you can think of a case like that, it turns out there is someone somewhere in Bulgaria or somewhere who really has this capacity and been but I haven't come across that. But if you did, then I think on the face of it, it would be very baffling how they were managing to do it in this analysis. But I agree, my reaction would be just exactly like yours. That what they're doing is some kind of grouping. That you say, well, let's see, you throw your 5 indexes and you say, bang, bang, bang. Each row has got 5 in it. There are 5 rows, therefore that's 25. Right? And now there are 3 blocks like that. Yeah. And so it's repeat grouping and so on. That would be my first reaction too. That you could try and explain it in those terms if you found that phenomenon. Yeah. Yep. More things at once. Yeah, the thing is, that would be the other analysis, that maybe someone is born with just 50 tags in their visual system, yeah, and I don't see why not. Yeah, I mean, it might be a bit confusing in ordinary life if you were managing to keep track of so many things simultaneously, but, you know, because, yeah, but why not? Yeah, I mean, I don't see why that shouldn't happen. That would be another hypothesis. It would be more, how should I say, it would be more radical. I mean, it would involve more of a departure from what people usually do than just having some kind of speeded up version of this grouping that we all can do, in fact, but I don't see why that wouldn't be possible, yeah. Yeah. But, yeah. Yeah. Yeah, I've never managed it at all. And the thing is, I was told this thing about football players being very good at this, and in fact, what I was told was that football players were able to do up to 10 targets simultaneously. But I've never actually seen any written down empirical evidence of this. All the studies I've seen have people topping out at about 4 or 5. But so I don't know. My knowledge peters out there. I have been told very authoritatively that this is possible verbally, but by someone who works in the area. But I've never seen a study that bears that out. Though I have to say, I've never seen a study addressing just that thing about training either. Okay. Okay, so that's multiple object tracking. If you're interested, as I say, go on to Polition's, just Google Polition and multiple object tracking, and you can have many happy hours trying this with different setups. One of the interesting things about this analysis is that there are mistakes possible. Remember Drechka talking about when you can make mistakes? You can make mistakes, after all, in your tracking of an object. It didn't seem like anyone in the class was coming out against and saying no against everyone else, but it's clearly possible you can make a mistake. You think you're keeping track of the object, but actually you've got it muddled up with something else. So it could happen that when you're being asked that one you were keeping track of, what colour is that, what shape is that, you might make a mistake about whether it was the object you think it is. But where's the possibility of a mistake come from? That was a question we've been discussing the whole way along. What does it mean, a mistake? In what sense is it only right? Is it right only if the tag's keeping hold of the same object through the exercise? Where does that possibility of a mistake come from? Well, a natural thing to say is, look, go back to Grechka. Just as you had the biological function of the magnetosome being to indicate the direction of oxygen-free water, you could say, well, this is what humans have. This is a human analog of a magnetosome. It's a biological function of a visual index to indicate where an assigned target is. That's what this is for, and that's why you have these things in your visual system. Just as the function of the heart is to pump blood, the function of the visual index is to keep a track of a particular object through an exercise. That's how come there can be going right or wrong, because there are these biological functions. Or you might say, well, if you had a causal connection set up at the start of the experiment, say when the 4 targets flash, or when you think that's Henry Jr. over there, and you're keeping tabs on Henry Jr., you might think, well, when you get something else muddled up with it, that causal connection, the causal connection with the muddled up object, depends on the causal connection you'd set up earlier with the right object. You see what I mean? When Calvin is trying to keep track of his mother and winds up following the wrong woman around the supermarket, then what has happened there is that he set up a causal connection between his mother and the tag. The causal connection between this other woman and the tag is there only because of the earlier causal connection. There's an asymmetric dependence there, in Fourier terms. Yeah, so you could say, well, I don't even need to talk about biological function. I can explain how tags can be getting it right or wrong using asymmetric dependence. Whatever exactly we say about that, you can say, look, tagging here is what Russell meant by acquaintance. Russell said, with acquaintance, we have a kind of connection to objects that is more primitive than any descriptive identification of them. And it's the foundation of your ability to think or refer at all. It's the basis of all communication. And Russell said, well, you can be acquainted only with sense data, you can be acquainted only with your immediate sensations. But this is giving you what Russell was talking about with acquaintance. What really does the work in Russell's notion of acquaintance is the idea that it's more primitive than knowing any of the properties of the object. You connect to the object in a way that's more immediate, more direct than knowing any of its properties. And Russell thought, well, you can only do that with your sense data. But this is showing a way in which your visual system can be doing exactly that with ordinary medium-sized objects. Your visual system tags medium-sized objects. My visual system tags the same medium-sized objects. That's how come we can think and talk about them. That's really the basic phenomenon at the making communication possible, this tagging of medium-sized objects. I know this is obviously naturalistic. This is just brain biology in the end that we're looking at. So there's nothing here saying, well, it's ectoplasm. It is the spirit that does it. Right? This is all perfectly part of the physical world. Well, what more do you want? Right? What more have we asked for? This is an important idea. Yep. Yes, that's what's happening. Here, ascribing the properties comes after the tagging. Yeah, but think about this case. When you're keeping track, you didn't see that anything. You see, it's pretty difficult to do the keeping track. And as I say, the basic finding there, one basic finding there is, and I'm sure there will be examples of this on the website, is that if these objects change colour or change shape in the course of the experiment, people don't even notice. You know, you're keeping tabs in a way that is more basic than seeing that anything. Yeah. I would try it. I mean, the finding is people can't do it. You can tell them they're going to change colour in the course of it, but if you pause to look at the colour, you actually can't keep tabs on the object anymore. You see what I mean? This is demanding, this task. Yeah. Yeah.
I'm saying,
right.
We're here in this case, we're looking just where the object is. And the other case, you could just look at where, what shape the object is. Is it just because we're focusing on one thing that we need to actually notice that thing and disregard other things?
Well, if you do this slowly, yeah, then you could, if as we're talking right now, right, you're not noticing, you're not thinking, well, what is this biological species? But I promise you that if I suddenly change into a lion or a centaur or something, you would notice. You see what I mean? It's not in general true that you only notice changes when you're looking out for what was going on in that dimension of the object.
Same thing you said for motion. I'm not thinking, oh, where is he now? Where is he now? Where is he now?
Okay, let's pick up on that next time. My sense is that we're right close to the end, is that right? Okay, let's continue with this next time. So we'll do more implementation on Wednesday.